Here's what you need to know about what is a switch. This is an exam topic in Domain 2, Network Infrastructure. By the end of this video, you'll understand the core concepts and exactly what to expect on the CompTIA Network plus exam. Let's get into it. A switch connects devices within the same network and forwards frames based on MAC addresses. It operates at Layer 2 of the OSI model and learns which MAC addresses are reachable through each port. Each switch port is its own collision domain, eliminating the collisions that plagued older hub-based networks. Key concept: MAC address table. Switches learn MAC addresses by reading the source address of every incoming frame. They forward frames only to the port where the destination MAC is located, not to all ports. Unknown destinations are flooded to all ports until the address is learned and added to the table. Key concept: Full-Duplex Operation. Each switch port operates in full duplex, allowing simultaneous sending and receiving on the same connection. There are no collisions because each port has a dedicated point-to-point link. CSMA-CD is not needed on modern switched networks. Key concept: VLANs and Segmentation. VLANs logically divide a switch into multiple broadcast domains. Devices in VLAN 10 cannot communicate with VLAN 20 without a router or Layer 3 switch. VLANs improve security and reduce unnecessary broadcast traffic without adding physical hardware. Key concept: Layer 2 versus Layer 3 switches. Layer 2 switches forward frames using MAC addresses only. Layer 3, multi-layer switches can also route between VLANs using IP addresses. Layer 3 switches combine the speed of switching with the intelligence of routing, eliminating the need for a separate router in many environments. Let's look at the full breakdown. Layer 2 switch, forwards frames by MAC address, one collision domain per port, one broadcast domain per VLAN. Layer 3 switch, routes between VLANs by IP address, combines switching and routing, eliminates need for separate router. Hub, contrast, broadcasts to all ports always, one shared collision domain, no MAC address intelligence at all. Here's a real-world example. An office switch has 48 ports. When PC-A sends a file to PC-B, the switch checks its MAC address table, finds PC-B on port 12, and delivers the frame only to that port. The other 46 devices see nothing. With a hub, all 48 devices would receive every frame, wasting bandwidth and creating collisions at scale. Quick recap before you go. 1. Switches forward frames using MAC address tables, not IP addresses. 2. Each switch port is its own collision domain. No collisions in full duplex mode. 3. Unknown MAC addresses are flooded to all ports until learned. 4. VLANs create separate broadcast domains on a single physical switch. 5. Layer 3 switches can route between VLANs without a dedicated router. That's what is a switch covered. Exam tip: switches =. MAC addresses, Layer 2. Routers =. IP addresses, Layer 3. On the exam, switches flood unknown unicast frames but forward-known frames only to the correct port. VLANs split broadcast domains. Switch ports split collision domains. Next up, what is a hub? If this helped, hit subscribe. New topics drop every week.